Swiss Aerial Guessr is a geography game that you can play on your console, and it's inspired by the GeoGuessr game, where you have to guess places all around the world based on Google Street View images. For Swiss Aerial Guessr, you have to guess places around Switzerland, but using aerial images, so this is the top-down view. I'm getting those images from geoadmin.ch. This is an API that you can use from the Swiss government that provides all sorts of map data, including aerial images. Let's play a round of Swiss Aerial Guessr together before we jump into the technical details afterwards. Before you can start, you have to set up a database, and you find the database folder here with all the necessary things you need for that. After that, you can run main.py, and at first you can choose your console color. So if you like to play this in blue or green, go ahead. I prefer the standard color. And then the first round starts right away. You see the first image popping up. Let's read the instructions together. You will see 10 aerial images from places around Switzerland, and you have to guess the place that is shown, and all the images are provided by Swiss Topo. So we start a new round. This is our first image. I don't know this place, maybe you do. So let's enter something random. Okay, so that was the hockey stadium in Davos. Then we have another image here. Here you already see one of the key challenges that I had during this project, which is that I have a medium data set. I would say it's around 120 places, but some of them don't have an accurate address yet, so this one is probably a bit off. Let's see what this was. Siki Park. Okay, I don't know it. Let's go to the third image. Okay, this is really cool. This is Verkehrshaus Luzern. You enter your answer here. Okay, so in the database it is Verkehrshaus der Schweiz. And it's always a bit tricky, because it's a bit hard to validate the answers. In this case, the similarity was 77%, and starting from 78%, you can score a point. So this was technically correct. And the next image is already here. This one is probably a bit off as well. And here, okay, this is Stadion in Wankdorf. Yeah. And image number 6. Okay. This could be... Is it the zoo in Basel, maybe? I think so. Let's try. Yeah, that was correct. Let's look at the script together. So first of all, we have this thing where you can choose a console color. Then we have some explanation text. Then we go into the while loop here. This lets you play the game again at the end. You can just restart another round without having to restart the script. Then we start the round. Then the image gets prepared. Now we get to the good stuff. First, we need a place to guess. For this, we need to first of all get one place out of the database, and then also the image. This is done with display image, and display image has a while loop that goes on until an image was found. Usually this is found in the first try, but if there's any error, it would keep trying until it can find an image. And for this, we query the database first for a random place to show. And after we get that one, we will check the cache folder if the image already exists. So the script makes this folder images, and in here all the images will be cached. So if the image already exists, then we can jump down here and just say, okay, we have found the image. Else, if it's not cached yet, then we would download it from the internet. And for that, we need to do 2 API calls. So first of all, in the database, there is an address, which you can see here. Every place has an address and not necessarily coordinates. So when you enter a new place, you can also extend the game by yourself. You enter only an address. And if there is no coordinates, the script sees that and makes a first API request to get coordinates for an address. That is one API endpoint of the GeoAdmin API. And if the coordinates are already here, it goes straight to downloading the image. So first of all, we do the request geo information. This is just getting the coordinates based on an address, and we give in the address, of course. And this is our first API call, which goes to this endpoint called search server. Here you give the address and then the type of coordinates. So there is 2 coordinate systems in Switzerland, proprietary ones that are not used elsewhere. And here you need to specify which of those 2 you want to use. And then we get back the response, hopefully, that you can then search for the coordinates x and y. Then we return those, and then a bunch of error handling down here. So after we have the coordinates ready, either we get them from the API or we get them from the database here. After the coordinates are ready, then we get the image. For that we do our second API call, request and save image. Here we give the coordinates, and we also need to give a zoom level, the address, which is just only used for the image name afterwards, and the folder. Yeah, this you could easily change this here if you want the cache folder to be another name, but this usually stays the same. What's up with this zoom level? If you check the database, you will see that every entry has a zoom value, and this specifies how close the aerial image should be. So if you specify a higher number, then the image would be much more zoomed out if you want to show an airport, or for example, and then you're in the lowest are like 400s usually, where it's just the Prime Tower in Zurich, for example. We can go into this API call here together quickly. First we calculate the corner points of the square that we want to download. This gives us this box, and then the service that we contact is WMS, and we want to get a map, and it's ch.swisstopo.swiss_image. This is the aerial image. And then this is very important, the box that's passed in here, and this is just a resolution, so I always download 4000 by 4000 pixels, which gives you some ability to zoom in, which is quite important for the game experience, that you can actually zoom in a bit and still see something. We get back a response and then save the image. And the image name is the address. So we get into that a bit later. Again, a bunch of error handling, and then we have the image. So after we have found it, we would then update the coordinates to the database. We copy the image. So every time there's a place to guess, the image gets copied and is named just current image. It's to not give away the place. And then we also try to open it with this call here, and that is also different depending on the operating system, but the goal is just that it opens itself automatically, so you don't have to always open it manually. This is pretty much it. Then also a bunch of error handling again. So then we have a place to guess, the image is there, we can notify the user. Then we get the answer. Here we can get into the answer validation a little bit. This was actually quite an interesting task and not that easy. So the issue is we want to also give the point if the user maybe has a small spelling error. And the other thing, which is even harder to accomplish, is that some places can also be named differently. So if you have a place which consists of 2 words, for example, Berner Münster, you could also enter Münster Bern, and it should still be correct. And that's not that easy to accomplish, I noticed. So first of all, we get a valid input, so we don't want any like symbols in there except for some, and that gives us the raw guess. And then we check it if it's correct. For that we give in the raw guess and the correct, what would be correct. And here we can already specify how similar they should be in order to get evaluated as correct. So we bring them in here, we do some cleaning, like make sure that the umlaute, etc. Don't mess things up here. And the main thing here is this token set ratio algorithm that I found. This is from a library called Fuzzy Wuzzy, very funny name. And here we take apart the two strings into tokens, and then we compare the tokens, which is a lot more forgiving than to, for example, just compare two strings literally, which would be very easy to throw off. And this here is a bit harder to throw off, but it's not perfect. We saw it together in when we did this quick demo together. There is some cases where we would say, okay, actually it's correct, but it was not similar enough with this token set ratio. So this is something that could be worked on in future versions of the script to improve this even further. Okay, yeah, then either it's correct or not, and we also, of course, say what the correct answer would have been. So after 10 places, the round has ended, and we will display the score to the user and also save this into the database, and then you get a little evaluation how you did compared with your previous round, so compared with your average, which is here. And that's pretty much it, and you can restart the game. And then we also clean up the logs as soon as we end the script and reset the console color. For this whole logging thing, I just came up with this because the fair use limit is 20 requests per minute. So in this game here, it's not too dangerous to go over this limit. But in a previous version of the script, we had a lot more calls going on. So there I implemented this logging feature. So every time you set off an API call, every time you set off an API call, we would log it in a simple log file, like so, just a timestamp. So this way the script automatically waits whenever there were too many calls made in the past minute, and it automatically continues as soon as it's safe to make API calls again. If you want to go into more details about this script, I have also written a documentation where you can read a lot more details. There is also a nice schema to understand the logic behind it better, and some comments about the technologies used, about the libraries used, how the thing with the database works, some stuff about compatibility and use cases, some test cases, and a quick reflection about my learning process. This is it. Download Swiss Aerial Guessr and have fun playing.